This is a video about using a Adafruit breakout board. It's an MCP2221 breakout board. I've got some single board computers like Raspberry Pi and Arduino, but I thought it would be interesting to try driving it with my interpreter, PW on a Windows PC. This is the configuration that we're going to be playing around with. We've got an Adafruit MCP2221a breakout board. It uses the MCP2221a chip from Microchip Technology Incorporated. It's a little bit confusing that up here it only says 2221, but if you actually look here, it says 2221a. Okay, it's upside down, but you can't have everything. It's a very powerful little chip or board. It's got GPIO, digital analog conversion, analog digital conversion. It's got an I2C communications bus capability and an SM bus communications capability. We're not going to use any of them in this video. In this video, our focus is on setting up the board so that we can talk to it from my interpreter, PW on a Windows system via the DLL driver. We'll talk to the driver and we'll talk to the chip to see that it's all there. I'll just introduce myself. I'm a retired telecoms engineer and I've been programming since 1971-72. But that's enough about me. Sorry, but there is a disclaimer. The video is for informational and educational use only. You can take copies of the RipeTech and Plodware applications from online from my website. The applications, command scripts, documentation are all available as is, and if you use them, I'm sorry, it's at your own risk. And other than being a user of some products from Microsoft, Adafruit, Arduino and Raspberry Pi, I have no connection with any of these companies, their employees, representatives or subsidiaries. The demo. Let's dive in. We're going to have to set up the MCP2221 DLL. It's easy, it really is. You'll need to go online to the microchip.com website, specifically to this website page. There I found, by scrolling down, a section called Embedded Software with a list of available software components. There was more than one page of software components. I had to go to page 2. And there I found the latest MCP2221 DLL, which at the time this video was created was version 2.2.1. Yeah, it's a DLL, but it's inside a zip along with other things. That's why you'll need the unpacker. I opened the zip file. There is a folder we're going to have to go into in a moment. But whilst we're here, do note there is a user guide for the DLL. And we'll have a little look at the user guide in a moment. But let's go now inside the unmanaged section. And there I took out from it the MCP2221 DLL x64. x64 because my system is a 64-bit Windows system. And because PW that's the interpreter we're going to use to talk to the hardware, is written in plain old C, which means it's a unmanaged application. So you need a DLL that's set up for unmanaged applications, and that's this _1. Take a copy of it, and I had to place it in my Windows System 32 folder. That's all you have to do to get the DLL side of this demo up and running. Of course, we've still got PW and the demo script. I am assuming that you will already have PWScripter. If not, it's in a separate video how to download it, but it's trivial. It's online. It's a zip file. Download it. It's a single file inside the zip, less than 5 megabytes. Just unpack it. This is where you can get the PWScripter and actually the demo script from. This is my website, www.ripetech.com. There is on the home page a link to downloads and script files, which takes you to this page. This is where you could get the PWScripter executable from. We're specifically interested at the moment in the mcp2221a setup file. If you double click on it, you will get a web page like this. Just copy and paste the entire text and drop it, or paste it into this area of PWScripter. That's what I call the edit panel. Down here is actually an overlay area where there can be lots of different types of panel. Currently it's showing the help panel. I'll set it in a few minutes to be a report so that when we have text being written out by the program, we'll send it to the report panel to see what's happening. It's camera action. There's our little chip. Now we're going to need our Plodware PWScripter. And I've already got a copy of the demo script. I can make the overall window a bit bigger. I'll change to the report panel. And I'll make this area. It's about 220 lines, but if you actually throw out all the space in the comments, it's about 102 lines, I think. We can make it all a little bit bigger if you have difficulty reading it. And we can run it straight away. What it does is, one, it tries to talk to the DLL. If that's successful, it asks the DLL for the address of some of the functions that are embedded in the DLL. And once it's got some of them, it will ask the DLL what version the DLL is. And it will then say how many devices are connected. If there is a connected device, it will speak to that device and ask it for some management information, such as the product version and other such things. It will not, in this video, drive any of the input-output or pins. The goal of this video is simply to get it up and running so you can see what's involved, and maybe with other videos that I've got, maybe you'll combine them into being the little application that you want. To run the script as far as it'll go, all I have to do is say execute lines, and it'll execute everything that's currently in the edit panel. But we should note we haven't got anything connected to the USB port, so nothing much should happen. But let's run the script quickly. It's run. There is some output. I'll make the output area somewhat bigger. Some general information, demo, where the sources for the 3 different components are, where you have to put the DLL, at least on my PC. Then it's checking for access to the DLL. That was successful. It's got an internal handle. It's asked the DLL what library version it is and how many connected devices. Let's just have a quick look at the code that's doing that. This is the actual call to the DLL saying, talk to me, tell me if you're there. PWScripter itself is case insensitive. It doesn't care uppercase, lowercase, but the DLL open interface does care because it's not from me, it's part of the operating system and it is case sensitive. So it tries to open the DLL. If it's successful, reports, okay, we have access. Okay, we have access. Then it talks to the DLL and asks it for the DLL and asks it for addresses of some routines. We're actually asking it for 1, 2, 3, 4, 5 addresses. The most interesting are get the connected devices and open by index. We actually call the get library version. You see here, library version. So we get the address. And then here we call a function, get driver info. This is where it's defined. And in there we call get library version with a parameter, a pointer to a memory area, which can be written into to hold a text string. We call the library get library version. It puts information into this memory area, which is defined up here. And then it prints out library version is, and it then converts that text into a character string and sends it to the screen. So library version 2.1. And it gets a number of connected devices and prints that as well. Nothing fantastic, fairly straightforward, bit boring because not much happened. So let's plug in our USB cable. Word of warning, at least with my system, if I don't plug the cable in fully, then the green LED on the board comes up, making you think everything's working. But for some reason, communication isn't there. I really have to push the connector cable in quite firmly. Then we'll rerun the script. There is built into the beginning of the script this statement, new script, which throws everything that it's done before away and starts with a clean sheet. So I just say rerun. This time we've got more output, quite a bit more. Let's make it a bit bigger. Now it's got one connected device. It's device index 0. It labels the DLL chip, DLL driver, labels the connected hardware with an index starting from 0. And we've got some general information from the device, factory serial number descriptor, etc., etc. And that is done. This is where we got the information about the driver. If the number of devices is not 0, then we come down here. This is where we say we want to speak to device ID 0. This is where we open by index, which is a call to the DLL to give us the connecting device handler for device 0. If that's successful, it gets some more links from the DLL. This time, these functions are concerned with talking to the target device. And we get from it a factory serial number, a manufacturer descriptor, product descriptor, these few parameters. And basically, that's it. Everything else now is using the chip to do input-output. But I'm not addressing that in this video. That's in another video. There will be, hopefully, little videos on all of these different capabilities. GPIO, digital analog conversion, analog digital conversion, the I2C bus and the SM bus. But basically, the demo, as such as it is finished. My thanks for your time. Until the next video. Cheers.